So can you see my PowerPoint slide?
Yes, Doctor.
So I forgot. So I'm going to share the PowerPoint slide with you in the WhatsApp group because I haven't put it in the e-learning. I forgot about this one. Mm, okay. 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 For today, we're going to continue on the introduction part on Wiki Dynamics. So based on our last class, Wiki Dynamics is actually one of important element of performance that usually going to be evaluated by the end user or the consumer when they want to buy a car. So okay, usually the manufacturers going to focus on three things. The first one is actually on the aesthetic appearance, engine performance, vehicle dynamics, okay, and then these are the three things that usually being focused on what being prioritized because these are the things that usually that going to be being taken what into consideration, a serious consideration among consumers, especially the vehicle design or aesthetic appearance. So meaning that if that car looks great, sometimes what the fuel consumption is too high, people still don't care, they still going to buy it. Okay, so the vehicle aesthetic appearance or the vehicle design are the first priority lah. They're going to decide or determine either that model going to be being sold with a high numbers of sales. Okay, and then for this one, which is on the vehicle dynamics, these are the list where we already took it. The vehicle dynamics, these are the position of the certain vehicle attributes, and then from this certain vehicle attributes, which is on the vehicle dynamics, we have another, this thing being narrowed down. For vehicle dynamics, we have from, okay, we have this one, vehicle dynamics. So okay, this one. So these are the very important. So when we talk about vehicle dynamics, we are actually going to focus on the handling, ride, steering, and braking. So on this key attribute, there are subsystems or mechanical subsystems that contribute to this one. For example, ride and handling is actually what a performance that be contributed by the suspension system, and then we have the steering that the one that going to determine the response of the vehicle, in, the meaning that which direction, meaning that that car will go into any direction that we want to go, and then it will stay in its track or in this path uh, uh, as it is, even when we don't give any steering put, meaning that let's say on you are driving on a straight road on the highway, so you don't steer your steering wheel, so you expect your car is actually moving in a straight line. You don't want at a very high speed, even though that you don't steer your steering wheel, suddenly you feel like your car want to go to left or to right. Okay, that is not good because because usually at straight road, what we want is that we usually going to drive that car at very high speed, and we should uh, what would like to maintain that course, so the direction. So we don't want the car to go to the left or to the right without any instruction from the driver or from us. Okay, so usually, okay, we will take a look at this one for steering. So there are active steering, and we are going also going to take a look at the passive steering system. So these are the things that going to help you or to assist the driver to maintain this course on a straight road. And then next one we have braking. So last remains braking. So braking is also important because it involves safety. Okay, these are subsystem. So okay, last time we stopped at this slide, right? Correct?
Is it?
Okay. So okay, so for up to this, so you need to remember four key attributes of vehicle dynamics, right, handling, steering, and braking. Okay, so these are the four vehicle attributes that usually, yeah, when you go to a Proton, these are the things that usually being looked at by the R&D department. Okay, and in R&D department there are several departments. One they call like for example, in Proton have what vehicle system integration department, if I'm not mistaken. So under this department, there are several sub departments. So there are sub department which focuses on the right handling. There are department which focuses on the uh, structural worthiness, which is this chassis strength analysis, and then there are department working on the CAE analysis. Sorry, the not CAE, the CFD for the aerodynamic package for that car. And then there's another sub department for electrical assembly, and then electrical and electronic assembly. The sub department for the vehicle integration. Okay, there's one department for vehicle integration. So vehicle integration is the one that going to assemble all these works from this sub department. Okay, usually for the vehicle dynamics performance for car that tends to be developed by Proton, usually it will be designed by the design department. They get the CAD data. The CAD data being done in CAD using CATIA, and then that CATIA model will be passed to the respective CAE department. So CAE there are two, which is the one that being the structural, and then the CFD, and then the vehicle dynamic right handling sub department. So these three departments are the one that are going to analyze the design in terms of its engineering performance. So for the vehicle dynamics, is the right handling. So this is where the engineer is going to do the tuning. So if you see that most of the what we say that in Malaysia, like I told you previously, in Malaysia, Proton's vehicle has the best ride handling. Okay, siapa yang pernah bawa kereta Proton, they should know lah. So you should compare between Proton car and Cordoba car or cars that the mid range vehicle lah. Jangan compare dengan high end. Compare dengan kereta yang mesti berayat behind ni. Okay, jangan compare dengan BMW dengan Merc. Okay, so compare antara Cordoba, Proton, Toyota, and then so Proton has the best one, and the right handling performance actually been done by the Proton engineers. So there's one person who been doing that, I think since Proton Persona. Sorry, Satria Neo been doing that. So there's engineer under him which come in and goes. Okay, but he's still there. Now he's already a lead engineer for the right handling CAE analysis. Okay, and then in Proton they are using a multi-body simulation, so they don't use MATLAB. Okay, simulating. So MATLAB is too mathematical because it's if they want to model the behavior of vehicle using MATLAB, so it's going to take a longer time because the equation need to be right. But using the software that Proton use, Adams, they've been using Adams since the beginning of the tuning work. So usually the Proton engineer they will do the that software we call Adams car, and then it has its own template. So you just need to get the CAD data of that vehicle and then put that CAD data into the vehicle, and then there's just going to determine the point of the suspension, the point of the bushing, tires, spring, shock absorber. Okay, they're just going to decide that, and then for initial design, they're just going to put just the location based on the one that being designed by the design department. So once they run the analysis, and they found out that the result from the right handling analysis from the Adams car does not meet their their test requirement, which they call it as the protons car DNA. So this protons car DNA, it has certain parameters that need to be passed, meaning that, for example, in the simulation, when they do the slalom test at certain speed, so they also follow the standard test during the simulation. So that car need to behave whenever there is a slalom motion within the simulation. It should not roll certain degree of angle. So let's say it should not roll about let's say about 2 radian, about 2 radian per second. It should not roll about 2 radian per second. So they need to make sure that the roll motion during the slalom test at that certain speed does not exceed that. So when it do exceed that requirement that they set via simulation first, they just going to increase the parameter value. Okay, so the same thing. These are the so there are other tests as well, like J-turn, slalom, double lane change, single lane change. They just going to and then they have skid test in the simulation. They're just going to make sure that all the parameters, all the points of the placement of this component going to produce results which meets their proton scar DNA. Okay, once it pass that one via simulation, okay, then they also going to look at a result from other departments as well. So this department, they're going to provide, okay, this design via simulation pass our requirement, and then they're going to start to do the fabrication or manufacturing design or the CAD model lah. Okay, once everything's complete, they're going to come out with their own or the first version of their prototype. They're going to test it again. So this time they're going to do the same test that they use via the simulation. That vehicle will be fully equipped with the instrumentation. So they're going to collect the data during the test. So the slalom test, the braking test, the double lane chain test, single lane chain test, and the skid test. So all these parameters will be compared again with the simulation results that they get from the tune parameters. Okay, they need to make sure that this result coincide very well. Okay, and then usually they're going to make sure that the percentage of error between the simulation result and the experimental data is no more than 5%. Okay, okay, you need to remember what this 5% of error. Okay, so meaning when you go back later on, when you go into industry, whenever you need to do validation, you need to make sure that it is a practice. You need to make sure that the result, the differences between simulation data and experimental data does not deviate by 5%. Okay, so right now, yes.
Sorry to interrupt, but I think one of our friends dah tunggu daripada pukul 11 tadi, dia tak dapat masuk kelas lagi.
Ini bukan betul sebelah dia masuk lambat ni. Saya pun nak tunggu dia. Okay.
Lim.
Okay. Okay, saya dah approve. Okay, thank you.
Okay, sorry ada
Okay, so, okay, saya dah approve. Okay, so important lah. So itulah, kalau saya cakap, saya lupa nak approve. So make sure what next. So please join early and then just wait for my bug approval. Kalau masuk lambat kadang saya lupa tu yang saya cakap. Okay. Kalau saya lupa, awak kena tunggulah. Okay. Okay, dekat mana tadi? Okay, 5% error. Okay, yang this one okay. Saya nampak slide-nya?
Tak nampak yang slideshow. Nampak PowerPoint.
Okay. Okay, nampak yang presentation mode?
Belum
Tak
lagi
nampak.
ada.
Doktor.
Yes.
just now I haven't scanned the QR code.
Itu saya ada cakap awak masa lambat waktu lepas saya takkan activate balik.
But sir, I start waiting at 11 eh.
Huh?
I got check with Daniel, but I waiting until 11:10, but still haven't allowed to get in
Tapi
until
kenapa,
11:20. Huh?
kenapa awak tak masuk sekali dalam list? Sebab saya approve bug mode dalam 11.10. Around
I'm not sure lah, but I start waiting at 11 lah. Because
okay.
I have check with Daniel mah.
Okay, later on kita akan tambah awak punya attendance manually lah dalam list. Okay?
Okay, thank you sir.
Okay, sekarang ni awak nampak
Nampak
saya
betul.
nampak? Okay, good. So yang that 5% error, so you need to make sure lah. Kalau contohnya, sekejap, saya boleh tengok dalam slide. Saya kena okay, so usually okay, and then that 5% of error is very important. Kalau awak macam kerja kat perusahaan Pro 2, they do this kind of validation, okay, for engine performance test, untuk vehicle dynamics. So anything that when it comes to performance evaluation, they will compare it with the simulation result, and usually they're going to compare the experimental data with highly developed simulation results. Okay, kalau macam di simulation results, kalau contohnya lah, katakanlah macam diorang dah design via simulation, so in experiment tu they did all the tests and then compare. Okay, let's say that they're doing the Salem test, and then they found out that the result is the deviation is let's say that 7%. So they will try to reduce that 2% of error, that so that it will fall again in that 5%. So they're going to determine to find out either the dia punya instrumentation sensors being slightly in the wrong position, or the parameters for physical parts is actually slightly deviate from the values that they want. For example, shock absorber, let's say that they want the damping coefficient to be about 2000 Newton second per meter, but if the supplier supply about 2100, so that one is slightly stiff. So that one also could contribute to these the differences of experimental data. So of course, when they compare with the initial result, so it's going to be more than they expect. So they will try to reduce or to remove excess 2% of error between these experimental data and simulation data. Because working with photons, for engineers, we know that this 2% might possibly be neglected. But when it comes to presenting to top management, okay, you need to remember, top management is not only few of them from the technical background. So for the rest, they're just going from the let's say like from procurement department or logistics, and then they're from financial, and then the bosses, okay, and then the top management. They will look at these differences, okay. As long let's say that there's something weird about your data, they're going to question you. Okay? They're going to question you. Why come they expect? Why come you don't do like this? Last time you can do it, but not this time. That one you can menjawab lah. And then this kind of culture, not at potong ni, all OEMs, all manufacturing companies. Okay, so yeah, I think I should share this one with you because should prepare with this kind of working culture in industry. Okay, kalau macam saya tak sure, so siapa yang LI ada buat kat Potan? Ada yang buat?
Honda Doktor.
Okay, Honda just assembly saja kan?
Yes. Tapi apa yang Doktor cakap tu relatable lah.
Okay. So it's everything like that lah. So siapa yang able to, it's actually a good experience, but you need to be prepared for that. Okay. Usually kalau yang mana saya tak bagi tahu memang dia merasa selalunya tak lama ada kerja hilang. dia akan tukar lah jadi buat jual insurans ke kan. Selalunya macam tu. Okay, tapi kena be prepared lah because it's actually good experience. Okay. Okay. Okay, now we go to the vehicle. Okay, this one is more related to the one that I told you now. So for vehicle dynamics, say for the classification of methods. So basically, when you have a new request or new plan from the top management that we should have a new car that program or new car that needs to be developed, usually they're going to release it. Each car program going to take time about 2 periods, but they're going to do this schedule. So you need to do something or something need to be released every year. Either that one's going to be a new car or a new facelift version of a car. Okay, and then based on that one, they can they have these what you're looking. This one is actually at the you're looking this one at the general cycle of phases for each car program. So basically, they're going to have a subjective or development. So this one from top management lah, they're going to decide. We want either we want to have how many programs. Either we want to have a new car development program plus one facelift program. So the management is going to decide. So the assigned project leader going to run this project lah. So he's the one that we're going to responsible in gathering all the principal engineer or lead engineer important. Okay, so this same structure that working in industry. So actually the same one that I'm trying to apply with you with your AD design. Okay, so you need to be familiar with it because usually okay. Yes. Okay, this one is okay. Usually for a new car program, okay, car program. Okay, usually it will be what one project leader. So this one you know lah, project leader. Okay, one project leader, and then under this project leader there's going to be lead engineer or we call as principal engineer or lead engineer lah. So lead engineer.
Doktor tunjuk slide lain ke?
Atau whiteboard.
Awak nampak tak whiteboardnya?
Nampak PowerPoint je sekarang dari tadi.
Nampak. Saya tulis atas ni saya share all screen. Sekejap. Saya contoh atas PowerPoint slide saya tadi. Dia tak keluar, dia tak nampak atas PowerPoint.
Oh, doktor masukkan in the presentation mode tak. Kita nampak Windows PowerPoint je.
Sekejap saya share whole screen. Nice. Okay, nampak tak saya punya note yang saya conteng kat sini? Nampak tak?
Yang conteng tak nampak doktor.
Nampak. Saya buat dalam kau pun buat saya. So nampak saya punya pembuat sekarang.
Nampak.
So now kalau macam dekat Proton, dia punya ada new car program. Okay, usually dia akan ada one project leader lah. Okay, under this project leader, there's going to be what we call kalau kita panggil principal engineer lah. Tapi dekat Proton tu dia ada panggil principal engineer ataupun dia panggil lead engineer. Lead engineer. Okay, so there are several lah. So this lead engineer, there's a lead engineer for lead engineer 2, 1, lead engineer 3, lead engineer. Okay, usually these lead engineers are the one that being heading the sub department within the vehicle system integration. Okay, so there are lead engineer for ride handling. There's a lead engineer for the CFD analysis or for the aerodynamics. Lead engineer for the structure analysis. Okay, and then lead engineer yang tadi lah, the one that I told you for the electrical department and then vehicle integration. And then under this lead engineer, there's going to be engineers. Okay, engineer. Dia engineer lah. Okay, sama. Yeah, engineer in this one. Yeah. Usually, when it comes to, okay, this is how the structure. I think Proda also practice the same structure for OEM. So like this. So we goes to the project presentation to the top management. Project leader going to present. Okay, project leader going to present. And then if there's an issue for that project, lead engineer will be called. Engineer bawah ni standby saja. So when there's another specific things, let's say that lead engineer explain that they say that let's say for example while working at Proton, there's an issue on the I think on the knuckle arm, if I'm not mistaken. There's a complaint from customer that Proton's car knuckle arm patah hal. So that one is actually the knuckle arm at the dia punya ni tu is actually a part which memang takkan jumpa lah kata knuckle arm ni patah. Okay, so they're going to do investigation. During the investigation, they will call engineer to ask technical advice. How come that thing possibly occur or possibly can happen lah. So they say that bagi tahu lah, memang usually that part won't fail because usually memang takkan fail lah. And then sebab benda tu pun load dia tak critical. And then they call the engineers. Lead engineer ni dia pun tak buat semua benda. He just know things that need to be done for specific area. So he going to delegate that task to the engineers under him. So it found out that this lead engineer will call the engineers which responsible on the knuckle arms design and specification. Okay, sebab dia tak semua part, as you know, in automotive industry, they're not going to make every part. They're just going to reuse parts that easily or already available. So you just mix and match. Okay? Unless it is a very crucial part and it needs to be done as a new component, then they will do it. If not, they're just going to reuse parts if they can lah. Okay, if found that they call this engineer, they're responsible for that knuckle arm. Say, okay, he already did because they're reusing the typical or common knuckle part for passenger or sedan car. So he say that he already decide to the knuckle arm to have certain price value, which is in terms of strength, meaning dia akan pakai knuckle arm ni should wear macam dia punya elasticity modulus yang, and then elasticity dia punya surface treatment macam mana, they can decide that kind of parameters and then send it to the vendors lah. So he said that he did that, tapi dia tak design lah. So then dia panggil vendor and then just do meeting with vendor, and then it found out that some of the parts that being supplied by vendors on that specific knuckle arm, there's a batch that don't meet or don't pass the quality check. So meaning that there are certain parameters whenever the vendor is actually being giving releasing the parts to the OEM manufacturer. Usually they're going to be QC check. So this QC check, as you know, they're going to take parts or components in batches, and then they're going to take a few samples, and then they're going to check whether these samples actually meet the design parameters that being set by the client. Okay, kalau meet, dia orang bagi lepas lah. It turns out that the few batches that yang fail to meet that this requirement, and yet the part still being released or being let to put on lah. So it turns out memang kena lah engineer yang bukan inilah engineer yang those who are really responsible for the parts procurement, kesian lah kan, he did the check. It's just that those batches tu terlepas sebab 1-2 sampel je yang error. So out of these ni, and then that sample juga pergi to consumer, and then bad things happen. Okay, so ini memang unlucky event lah, and then unlucky event, and then adalah ini bad story lah. So dekat engineer, dekat Proton ke dekat Produa, if there is bad things happens, and that bad things actually being actually being seen by your top management, especially CEO, CTO ke apa kan, usually there are people that being fired on the spot. Okay, yang ni case ni bukan kena fired lah, dia just dia orang just unlucky events saja lah. Tapi ada juga lah yang saya tak cerita, ada yang few events yang memang staff kena fired on the spot, okay, ataupun tukar immediate. So this one you should expect. Kalau macam kilang masalah in top management, this kind of culture exists. So you need to be aware lah. So okay, this go back to this program structure. So car program structure. So basically these are the one that we're trying to adapt or introduce you to the for automotive in automotive industry. So ini yang Eddie punya cerita lah. Okay, itu je. So kalau okay, ada apa nak tanya tak pasal apa how things or apa project flow works in cars manufacturers. Ini saya baru cakap pasal academic lah, introduction. Okay, ada soalan? Okay, kalau tak ada, go back to slide.
Kalau doktor, satu soalan. Kan doktor cakap about yang eksperimen punya data tu. So siapa yang akan jalankan eksperimen dekat test track tu nanti? Is it like
Usually let's say that ni good question. Usually in cars manufacturers, let's say that you have you need to do your job, and your job is just to do your simulation, but you need to validate your simulation result with experimental data. And then doing experiment is not your job scope. You need to order the apostrophes break open and close bracket. You need to order that job from the test department. So you just need to, usually kalau benda, if it is a routine test, you just order the work, they will know lah what to do. But if it's a new kind of test that you want to conduct, you order, and then you will need to assist that technical or test department to do the test on your behalf. Okay, sama lah macam other department pun, contohnya macam you want to, let's say your job is doing CAE analysis, you don't do the CAD model. You get the CAD model from other department, you order lah. So usually it shouldn't be no problem, because if they're aware that you're working on the same project that they've also been working right now, so there won't be any question. You just order that work of CAD model from the design or CAD design department, design department. So that personnel in charge for that, you're going to make it using and pass the model to you. Okay, so from that you work out, and then you're going to proceed, do your work lah, and then you confirm everything, and then you want to validate your simulation result, and then you order lah experimental test from the test department. Okay, and then macam tu lah, you don't have to do everything, you work with your scope. And that industry, a big company lah. Kalau if big company is like this, you don't have to do everything. So if it's outside of your job scope, you don't have to pening kepala or have a headache to think how to do it. Okay? Because if you're a small company, yes, of course you need to do everything. Okay. If big company, this kind of work culture or practice that being conducted lah. So sama lah macam dekat Pro2 pun dengan Proton. Sebenarnya dulu last time we have R&D activities both Proton and Pro2. Now I believe for R&D activities only Pro2. Proton doesn't do any R&D activities anymore because most of the R&D is just be done in China, okay, by Geely Group engineers. In fact, right now, Proton engineers, in Proton right now, they're still maintaining the R&D engineer in the R&D buildings. It's just that most of these engineers, they will be seconded to the Geely's engineering R&D center in China. So they usually they're going to rotate every month. So there's going to be an engineer that need to go to China. So at the beginning engineer ni suka lah, tapi lama-lama dia orang makin they choose not to go to China. Okay. Okay, so kalau yang baru fresh untuk experience, yes, it's good lah. Tapi kalau macam saya pun, saya tak suka lah travel selalu kan. Kalau sekali-sekala macam for first time, yes, but for too frequent, nak sebenarnya tak. Saya ini depends on people lah. Okay, any other question before we
So that means ada another department lah under the project leader yang buat all the tests and everything.
Ya, akan ada department lah yang akan assist you. You just monitor. Kalau that test, especially kind of new test that never been done before, so these engineers that requires the job, so they can assist lah. So engineer sebab yang test apa semua, you duduk tepi, tengok lah dia orang set up. Kalau nak join lah. Kalau tak nak join, dia orang tak ada kata apa. Tapi usually, yelah, kalau ini dia orang terlibat sekali lah. Okay.
Thank you, Dr.
So ni ada question. Good. Okay, for next slide. Okay, nampak. So yang tadi lah. So subjective development. The top management is going to decide new project. So this project will be held by one project leader. Under that project leader is another project lead engineer. So they're going to work on these elements lah. Yang tadi yang kita ada 13 tributes kan for car development. So there's always lead engineer for that elements, or maybe possibly one lead engineer going to being responsible either to 2 or 3 elements, and from that 13 vehicle attributes. Okay, and then once they have design, the design department going to pass the CAD model for the CAE analysis. For the CAE analysis ni, they're going to do the right handling analysis, structural analysis, which is involving the crash analysis, and then CFD analysis to check the airflow or aerodynamic around the car, because that one also going to affect your fuel consumption. Because this one are the things that we're going to look on later on. Because aerodynamic or aerodynamic drag is actually the one, also one of the elements that affect your fuel consumption a lot, other than the engine performance. Okay? So and then the objective last is the testing lah. So this one we do like I told you just now, we need to carry out the testing to validate the CAE results to confirm our design. So if and then we need to make sure that the differences or the error between the simulation result and experimental result does not exceed more than 5%, and if it does, so they're going to investigate either the model is wrongly being defined, which is usually not, because that engineer in Potan, they're very particular because they know if they don't be very particular, the bosses going to sound lah. Okay, usually the differences usually being caused by the slightly slightly relocate sensor position or slightly slightly produce parts with differences in terms of the parameter value. So that kind of thing that they're going to look at that. So once they do the correction, they inform the manufacturer, the supplier, the vendor going to do the correction and produce the part with the parameters that they want. So usually the percentage of error will fall within 5%. Okay, so that's how the general cycle of a car in automotive industry. Okay. Okay, now we go to the vehicle dynamics. Previously, we already talked about what is actually vehicle dynamics. So vehicle dynamics is all about in general, it's all about studies about kinematic and dynamic behavior on a car. Okay, so meaning that we are studying about what cause kinematic motion for a car. So when I say kinematic, it's going to be acceleration, displacement, velocities, angular motion, roll rate, pitch rate, and yaw rate. Okay, so but basically, okay, so that's previous definition, and then okay, so same thing. So vehicle dynamics also expression that encompass the interaction mostly between driver and vehicle. So fundamental objective of vehicle dynamics is all about active safety through controllability and stability. So meaning that okay, nampak slide sebenarnya?
Nampak Doktor.
Okay, usually dalam vehicle dynamics ni, the reason we are actually focusing on vehicle dynamics or element or study on car is that we want the car to be controllable and also stable. So meaning that it will not cause accident to the driver. Okay, in terms of controllability yang tadi lah saya cakap. So whenever the car will go in any direction that we want to go and will not move or will not do anything if we don't put any effort on the steering. Okay, so meaning that kalau straight road, awak bawa laju atas highway, if you don't steer the steering wheel, so you expect the car will move on straight road lah, okay, tanpa without going to the left or to the right. Let's say that macam you've been driving in a very high speed and then you let go your steering wheel, and then your car is going to be in the same lane. You're not going to go to the left or to the right, okay? Because it does, and then something wrong with your the car tuning is not good, or your car needs a new alignment, tire alignment. Okay, under this controllability, we have cornering stability or straight ahead stability. Yang the one that I briefly described right now is just a straight ahead stability. For cornering stability, is all about precise and confident steering control, meaning that the car will go. Let's say that you are been driving your car at very high speed, and then you want to take a corner. That car will go or enter that corner without you having feeling of that car will overshoot. Okay, meaning that you're going to enter the corner without the need of reducing the throttle or by pressing the brake. No, you just need simply to maintain your throttle and then just enter the corner, and then your car will enter the corner without without you feel any hesitation. So this one is a good good suspension tuning for a car. Okay, usually for Proton's car, no problem lah. BMW car, Mercedes car, usually they won't have this kind of problem lah, which is taking corner at very high speed. Okay, cumanya for low macam low cost car macam kita Produa, Azia, especially kancil kalau awak masuk corner 80 km pun awak kena tekan brake ataupun kurang kan. Kalau nak masuk 80 boleh terbalik lah, especially older version of Produa car lah, for example kancil, Kenari, especially Kenari lah. Okay, you feel that car is going to topple at the corner. Okay, next one we should have on the car design is the stability lah. So we have the translational stability, cornering stability, same this one. So straight edge stability. So especially for this stability, for the translational stability involving the lane change. So if you realize, let's say even for especially older car of Produa, a straight road, if you are driving on the highway, even though that you manage to take overtake a car in front of you, this one also applies to Myvi lah. Okay, so even though that Myvi can overtake a car in front of him also, so basically you're going to feel what like the car, this bit instability of your car. So you need to hold your steering properly lah. So okay, not compared to other car or sedan car. So you just need to take without for you to do any excessive steering correction. Okay, so our objective in terms of having a stability is that when we overtake a car to do single lane change or double lane change, you don't have to do correctional steering. So just steer to go out from your current lane and then maintain in the next lane, and then steer back to the your first lane to overtake the car. So without for you to do this correctional motion on the steering. Okay, so that one we can say that the car is actually having a good translational stability. Okay. Okay, so any question for this one?
No question, Doctor.
Okay, now okay, by various means of interference of the driver can interfere the vehicle. So basically dalam vehicle ni kita ada okay, usually when for vehicle the way that we are controlling our car is only through steering wheel, brake pedal, okay, steering wheel, gas pedal, which is the throttle, brake pedal, clutch. This one for the manual transmission vehicle, and then gear shift lah. So gear shift, auto transmission, tetap ada gear transmission daripada D, gear 2 and gear 3. Okay, that's the only input that we can give to the car in order for the car to behave or provide the stability that we talked about in the previous slide. So you need to have the controllability and stability, and that controllability and stability is actually it's like still a general term, and there's another specific term which is this driver inputs are the one that are going to affect the motion of the vehicle. Okay, which is the controllability and stability lah. So this controllability and stability will be further defined into the lateral direction and longitudinal direction. So when I say about lateral, so lateral actually means the sideways of the vehicle, and then longitudinal ways meaning that the forward direction of the vehicle. So ini saya dah pernah tunjuk vehicle axis system sebelum ni. Ada dalam ni ke? Previous slide ke? Next slide. Okay, sebentar saya. Okay, this one. Okay, akan ada. Okay. So this input are the one that akan affect kita punya controllability and stability. And the controllability and stability that we are talking about is actually the lateral motion or lateral dynamics and longitudinal dynamics. Okay. So ini kita akan tengok later on based on the axis definition in next slide. So and then later on, once the driver give the input to the car in order to control it, and then the car will also give a response or feedback to the driver. Okay, meaning that if let's say that we want to steer the car by steer the steering wheel, the car will go into the direction that we want. Either it go in the direction that we want, or it will there is some lag in going into that direction, or there is going to be an overshoot. Okay, itu depend lah. Okay, and then this is the feedback from vehicle to driver. So we're going to face some vibrations, and then this vibration it comes to three axes: longitudinal, which is in the forward direction, lateral direction, or in sideways direction, and also in vertical direction, the up and down motion of the chassis. And then the car is also going to provide to the driver in terms of sound coming from the engine, the transmission, the aerodynamics, and tire. Okay, the sound, tire contact between the tire and the ground. So usually for engines, okay, right now, due to the technology advancement for automotive field, usually the engine sounds we can reduce. Okay, there is in fact this sound usually in car development, this vibration in sound, we put it under the we call it as a noise, vibration, and harshness. And then there's a study that usually being done by the there's also subgroup that also focus on specifically on the noise, vibration, and harshness. Okay, meaning they're trying to reduce the sound that caused from the engine, or the sound that being caused by the aerodynamic or wind outside the car when the car is moving very high speed. Okay, so for vibration, this one for car, for passive one, to reduce the vibration, usually they put insulation, and then any mounting point, they're going to be mounting, rubber mounting, or polymer mounting. And then they're also active, meaning that they're going to be a motor that piezo motor that going to also vibrates, but it's going to vibrate in opposite direction. And then when it does that, it's like going to cancel out that vibration, as if it is absorbing the unwanted vibration. So in the end, the driver and the passenger won't feel the vibration. So this one is on active advanced system lah. So ini kalau ada, ni saya cover lah ni dalam advanced subject master. And then for sound, this one they are focusing on engine mounting. They are reducing by engine mounting, either the material of the engine mounting or the configuration of the engine mounting. Okay, if you realize lately for Proton Star, starting from Proton Persona, there is a significant noise reduction, which is the NVH improvement for Proton Star, starting from Proton NVH. And then starting from that model, Proton Persona, later for Proton Persona, and then Izora facelift, every Proton car has a very low noise, either coming from the engine, or either coming from the wind at very high speed. Okay, sometimes if you are entering a Proton Persona, a new car, you see inside there, and then you start the engine, you won't hear the engine sound vibration at all. You will think that ada ke tak dengar bunyi engine pun, lebih kurang macam tu lah. Okay, cumanya ada sikit lah, cumanya nanti over time the engine's rubber performance it will reduce lah. The rubber material will start to hardening. It's going to reduce the NVH performance a bit lah, but still better than the previous version of Proton Star. And then what Proton's engineer did is that this department, I was there when they're doing the work, they actually can change the configuration of engine mounting from 4 mounting into a 3 mounting position, what they call as pendulum. So they are actually in pendulum mounting configuration, they are in 4 points, they actually there are 4 points used to hold the engines. Okay, so meaning that points actually at some point is actually restricting the motion or vibration that comes to the from the engine. So where they are for when this configuration restricting the vibration, that vibration will be transferred to the chassis, which in the end it will be transmit to the passenger and the driver. So they changed to the idea of to 3 points pendulum configuration, where the idea is that to allow that engine to allow the vibrations to occur, but they're going to channel that vibration to the mounting lah, rather than totally restricting the motion, restricting the vibrations. They allow it to vibrate. It's just that vibration being channeled directly to the engine mounting. So by doing that, they're actually increasing the effectiveness of the shock absorption from the vibrations. So that's why they managed to reduce the vibrations coming from the engine very significantly lah. So this one Protons, they are actually during that time they are trying to follow the idea from from Nissan lah. Nissan actually the first manufacturers that trying they're applying this 3 points pendulum configuration for mounting points. But the idea is that they just don't ask Nissan lah how to do it. They just know that Nissan been using this 3 points mounting configuration, and then they do it themselves by through distribution analysis using the multiple distribution. Okay, yang saya cakap tadi lah. So they managed to do that. So ni starting from that, their workflow becoming a reference lah for future Proton car. And now even when Geely take over Proton, some of Proton expertise that Geely don't have. So they're using Proton's engineering expertise to improvise their motion, their model, especially the right handling. So right now, the latest for any, for example, for Geely's car X50, X70, when they come into the Malaysia market, they not only they need to change the left driving side to the right hand side, but they also need to do the retuning, and then this suspension tuning being done again by the Proton's engineer. In fact, realizing that because this person has the same skills as the Lotus engineers, so my friend, this is actually my friend, so Mr. Mazuki, so he being called to the Proton Geely to do the suspension tuning for Proton's car, okay, for Geely's car in China, okay. So if you take a look closely, during early Geely's involvement in automotive, so there's issues on the vibration, right handling. So not after, so when they took over Proton, so this kind of lack on their model be provided by engineers. So there's the advantage of taking over of other car companies. So you can grab the technology or the expertise from each of the company that you took over for your own development. Okay, contohnya for example Geely ni kan at the beginning he took over the Volvo, and then he just take the Volvo technology on the chassis. So when it comes to he also take over Lotus. So in Lotus they're more on the design on sports cars, so they took over this expertise. Not took over, they just asked the engineers to work in China. That's it. Okay, they just we just need to have money lah for that. Okay, and then go back. Okay, so we go back to the slide. So feedback from vehicles, and then another one is the feedback that being provided by the instrumentation. So ini kita ada accelerometer, gyrometer, external temperature, GPS, and LVDT. Okay, last time this instrumentation, there is in a location that hidden location in the car, but there is this kind of sensors. It just does during my time. Okay, I just heard this one. I heard about accelerometer. I heard about gyrometer. I heard about what temperature sensor, GPS, LVDT. Okay, LVDT stands for wire transducer. It stands for linear variable differential differential apa tah, tapi ini macam it's more like wire transducer, meaning that if you have a sensor with a string in it, you just pull out that string, it's going to measure the displacement. Okay, so during my time, all of these sensors tak accessible lah. It's actually inaccessible, and if I want to access these sensors, it's quite costly. Okay, compared to you guys right now, all of these sensors are actually very cheap. You can even bought it from Lazada or Shopee, and you can even try to manage to use this sensor by using Arduino or Raspberry Pi. Okay, so that's why you are very lucky nowadays, because technology keep on advancing. You are lucky to do this one, because ini during my time when I was a student, I really want to have an hands-on for this sensor for vehicle instrumentation system, because CAN system, because during my time it's actually, even though it's actually a simple thing, you cannot even buy it. Okay, usually during in early 2000 where all these advanced system like ABS, GPS, electric power steering, anti-lock braking system start being applied widely. As a student, we cannot access that system, even though that is just using a simple CAN. Okay, if you want to access to that system, you need to have a special instrumentation, and that instrumentation is very expensive, and usually only researchers or lecturers with a special project, we usually have a millions research grant, will buy that equipment. But nowadays, you can already access vehicles control area network by using Arduino and Raspberry Pi. Okay, very interesting right now. So if you have time, you can start to develop this kind of interest on your own, because it's actually good skills. It's actually good for you when you go out and try to look for a job, because nowadays, people are emphasizing on IR 4.0, and for me, IR 4.0 is actually those who are being exposed to the mechatronic field. Okay, it's just that right now they're trying to apply this mechatronic field not only limited for mechatronic students, but also into other fields as well, for engineering, let's say chemical, because it just involve the data monitoring or big data, things like that lah. Okay, so if you can learn, so this is going to be very good for you lah. Okay, so later on, ini promosi lah. So later on, okay, maybe possibly if you want to learn how to use, I think early next year, after the end of second semester for this session, I will be having or conducting what we call as a graduate upskilling program. So I will open a short course on how to program Arduino using MATLAB Simulink. So this topic is going to be advanced lah. So if you want to join during that program, so please lah. But mostly I'm just going to mostly of things that I'm going to taught in that short course is actually the one that I'm going to teach you during vehicle dynamics subject and AD. Okay, so it's just that you won't get it it's just going to being a gap lah from stages to stages on how to program Arduino using MATLAB Simulink. In fact, if you like, we can also make this Arduino to talk with the Raspberry Pi without any coding involved. We're just going to use Simulink block. Okay, because it's very important for you to do, because this one in Proton, their engineers are also expected to do this rapid prototyping. So meaning that any control system that if you can do on yourself without relying on the vendors to do the setup for you, you better do it yourself. Because if you want to ask vendors to do the setup for you, let's say for example you want to make a control system to control a power window, you have the codes, you have the algorithm. It's just that to do the setup, you don't know. So you need to ask the vendor to do it for you. And then to do that, you need to do paperwork, asking for budget. Itu yang leceh sikit lah. So if you want to skip that one, so you need to know how to do it on your own. Okay. So any questions on this one? Ada soalan? Okay, now this one is a vehicle coordinate system. So this is actually a standard axis system defined by the SAE, Society of Automotive Engineers. So basically, for a car, we have three axes. X axis is this one, so pointing towards the car direction, and then the pitch axis is referring to the sideways direction, and usually the lateral axis is being considered positive towards the turning radius or towards to the centripetal, centripetal direction. So that one is positive y-axis. Okay, usually when the car, let's say the car is turning to this direction, let's say to the left side is actually being considered as positive lateral axis. Okay, and then we have vertical direction. So each of these axes, x, y, and z, we have rotational motion. Okay, this rotational motion, if you look at the x-axis, the one we call as a roll motion, and if we look at the lateral axis, that one is pitch motion. For z-axis, that one is yaw motion, how your car turns. So that one is yaw, and then the direction of motion always in counterclockwise position. That one's always being considered as positive. Okay, so you need to know that, because later on, if you don't follow this notation, usually when we try to model a simulation model using mathematical equation, it's just going to affect your plus minus values, and then if some of parameters you are following the notation of sign, and then the other of parameters you're not following the sign notation, and then the value is going to be different lah, unless you if you want to change, if you want to use for rotational motion, every rotational motion is following clockwise direction, and then use every rotation is using clockwise direction is positive, then it's okay. But if you use some of it, use a standard sign for rotational, which is following the counterclockwise, and then the next one is following clockwise direction. So when you sum up, it's going to give you a wrong answer lah. So this effect we're going to see later on, because we're going to model vehicle ride model using MATLAB Simulink. Okay, for this one, let's say for longitudinal motion. For longitudinal motion, we are actually focusing about for x-axis, we are studying about longitudinal motion, lateral motion, and vertical. So longitudinal motion is most likely this one is for keluar, still tak keluar. Saya punya line yang saya conteng.
Keluar tak?
Keluar tak?
Tak keluar. Ya, saya kena dah keluar, saya kena padam lagi yang conteng. Okay. So usually for longitudinal motion, we are studying about this one is a brake. It's about in general lah. With this one we studying about brake. This one we are studying about related to steering. And then this one we are studying about comfort, suspension comfort. This one in layman term for why or what. Of why we are studying each
Okay. Saya tak buka mic. Okay, good. Okay, dengar tak suara saya sekarang?
Dengar Doktor.
Okay, saya baru
Betul.
tadi. Okay, patutlah saya tukar saya punya apa mic sebab tadi tu bateri nak habis. Saya tukar yang baru ni, saya lupa tekan unmute button. Okay, now mana kita tadi? Okay, nampak slide PowerPoint ni?
Nampak Doktor?
Okay, so basically, like I told you, in car axis, we have three, X, Y, and Z. With X axis is actually about longitudinal motion. Y axis is about lateral motion, and your axis or vertical axis is about your motion. Okay, and then for each axis, we are actually studying that axis in that direction, just for one single purpose. For example, if you are studying longitudinal motion, okay, longitudinal motion is all about acceleration performance, braking performance, okay, acceleration, okay, acceleration performance. Nampak ni saya tulis acceleration.
Nampak Doktor?
Okay.
Nampak.
And then for longitudinal, it's all about acceleration performance. And then it's all about braking performance. And then for steering, it's all about we are studying about about safety. Okay, steering response. Okay, and then we have for electronic stability control. Okay, and then kita ada ini advanced traction control. Okay, ini yang bahagian topik advanced topic on vehicle dynamics. Okay, ini ada braking, acceleration. We have ini kita ada traction control. And then for this one, and then kita ada ABS, anti-lock braking system, electronic braking system, electronic EBD, okay, electronic braking distribution. Okay, these are, and then for vertical, we are about studying about comfort. Okay, about comfort, which is the suspension lah. Okay, these are the reason why we are studying this axis of each axis on the vehicle, because the fundamental studies are the one that are going to produce something that is quite useful to assist us to have a car with a good controllability and stability. Okay, contohnya yang tadi lah, especially yang ni lah. So usually for low speed, we are really want to emphasize on the comfort lah. So meaning that when you hit the bump, you won't feel that you are actually hitting the bump. So like nothing. Okay, that one is very low speed, but at very high speed, you prefer not to have a soft. Yang tadi tu, when you hit the bump, you won't feel anything. That one is what we call as a soft suspension setting, and it's very good at low speed. Okay, but when it comes to high speed, we don't want the suspension to have a soft tuning, because it's going to affect our car dia punya stability. The car with soft suspension tends to have a roll at the corner, okay, especially at very high speed, to tends to topple lah. Okay, so we don't want that. Okay, so that's why we're studying this one. So and then for lateral axis, we have about the study on lateral motions to study the steering response, meaning that whenever you provide the steering input to the steering wheel, your car will go into any direction that you want without any lag or without overshooting the path or corner. Okay, and then from this study also, engineers come out with what we call as electronic stability control and traction control. Okay, traction control traction control not traction control. Traction control is for this one. Okay, so it prevents sleep. So it's fall under the longitudinal motion studies. And then for this one, we have a new one, what we call as a torque vectoring. Okay, torque vectoring. So this one, I believe in another 5, because this one, torque vectoring, is like a latest technology on vehicle stability, and I think it being applied in 2015 by Audi, but it's not famous during time due to the cost on the technology. And right now, usually this kind of technology going to be, especially this one for stability, it's going to become standard within another 10 to 15 years. For example, same goes to the ABS system. Last time during my time, the ABS system in 2000, year 2000, is actually an optional, which is an expensive option for those who want to buy a new car. But nowadays, the ABS, EBD already become a standard option for a car for safety purposes. Okay. And then for torque vectoring, in torque vectoring, this one we're going to talk later on in handling stability, because I'm going to discuss briefly on this technology on vehicle controllability and stability, because the technology like ABS, EBD, torque vectoring control, electronic stability control, traction control is actually being derived from in-depth understanding on vehicle dynamics or vehicle behavior. And then for suspension, okay, for comfort. And then for comfort also, we're going to take a look at the normal comfort level of vehicle. We're going to model the suspension. And then, possibly I'm going to introduce you some control system. So for this semester, we're going to, and then, we're going to do hands-on what we call as a hardware in loop. So meaning that you're going to apply some of your control algorithm in hardware in Arduino, and then we're going to check the reliability of the control system by using Arduino or Raspberry Pi if you have Raspberry Pi. Because back in industry, and these are control system for vehicle dynamics control system, when the way that I've seen them they do it in the industry, is actually very expensive. The cost for the hardware alone can cost about 1 million, 2 million, million, it comes in million figures. So the one, if you can do it just only using Raspberry Pi, Arduino, and then you're going to wow your bosses lah. Okay. Last time, in fact, when I worked in Proton, I did demonstrate this one. But masa tu kita pakai software MATLAB, so almost terkantoi lah saya pakai MATLAB academic version kan. So sebenarnya dekat dalam industri tu dia orang tak boleh pakai yang MATLAB yang academic versionnya. So tak apalah, kita dah buat, kita buat menjawab je lah. So later on, and then satu lagi, when you work in industry, in the your company area, so try not to use any pirated version software, okay, because it can be detected. Okay, right now pun kalau awak pakai dalam UTM ni software dia punya software owner, they won't care because they know students been doing that. And then also they also aware that there are versions of software being used by the university or already being subscribed. It's just that when it comes to students, they cannot control the use by students. So they just pejam mata lah. Tapi kadang-kadang tu ada juga software owner yang sue the university to take responsibility on behalf of students who use pirated version. So this one very careful lah. Kalau university mungkin usually jarang lah kena saman, kena sue balik. Tapi for industry, don't use pirated version. If you want to use it, use at home. Don't bring that software to within the Proton's area compound ataupun Produa area compound. Okay, because once it been detected, they will call the IT department lah for that manufacturer, saying that their software being used as a pirated version. So silap-silap memang kena saman lah. So usually memang dia orang akan carilah siapa yang pakai tu. Sebab ada juga masa saya dulu ada vendor yang datang, dia buka sekejap je pun pakai Cellular Work pirate. So the way that this software work is that whenever you open the the software, there's certain log file in text that will be automatically produced, and then it will send via the internet in the background without you knowing it to the HQ, to the server. So they're going to of course they're going to do decoding to cross check either that IP for that laptop that opening that software has the license. So if not, memang dia check, tengok dalam kawasan Proton, tengok Proton tak ada beli software dengan dia orang, memang kena lah. So silap-silap, there's a few cases where automotive OEM being sued, okay, by the software owner. Ada yang Katia adalah dia bukan adalah kes ni, saya tak nak bagi tahu lah, tapi ada Proton tak pernah kena lagi lah, sebab memang Proton dia jaga betul, dan software supplier ni dia orang tahu kata Proton memang jaga, kata tak bagi pakai software pirate. Mana-mana staff yang pakai software pirate ada yang kena fired. Okay, dia memang jaga. Cumanya sekarang ni yang vendor tu tak boleh buat apa lah. And then ada juga case where the software owner ni sue and then ambush or go to the vendor's office with a lawyer, apa semua tu lah, nak saman apa semua tu. Itu vendors punya cerita lah, adalah company-nya, sebab this vendor pun quite famous lah. So possibly in the future, kalau awak dah kerja pun awak possibly akan kerja dengan that vendor lah. Okay. Tapi saya rasa sekarang ni vendor tu dah insaf kot, dia pakai yang ori punya. Okay, cumanya nanti saya tak nak beritahu nama lah. So nanti, okay, sebab vendor ni pun agak besar agak, dia memang terlibat projek dengan Proton. Dan saya rasa later on when you graduate, you're not only going to work with the Proton, but you also will work with Proton vendor. Okay. But in my case, my opinion, rather working with the Proton, you better work with the vendor. Okay. With Proton, right now with nowadays environment, Proton being put under Geely, there's nothing much interesting that can be learned lah. Okay. Because everything is there, you just need to make sure that the parts being assembled, being selected properly. There won't be any R&D activities compared if you joining vendors. Vendors still need to do R&D. Okay, for it doesn't matter lah for Proton Produa. And then if the vendor don't work for Proton Produa, they're still going to work with other car companies which requires R&D. So the one very interesting. Okay, any question on this slide?
No, Doctor.
Okay. Ini terminologi. Okay, ni habis. Okay, ini yang terminologi untuk handling. So basically, okay, yang tadi lah based on this axis, referring on vertical axis, if you look on top of the vehicle, so we're going to have this certain terminology that you need to understand, and this terminology is actually being used applicable for the handling motions, which is when we are studying about the lateral motions or lateral dynamics. So let's take a look at the first one, which is the easiest one is the steer angle. So the steer angle is one. So we have a steer angle is actually the amount of your wheel being steered by steering wheel. And then once you steer this one, it will change the car motion. So the car will start to rotate about z-axis. That one we call as a yaw motion. And yaw motion, which is this one. Okay, yaw angle. We have being measured about this axis. Okay, about the axis, we have two type of axis over here. We have what we call as a global axis, yang ini yang besar punya, in real wheel punya axis. And then the second one we have is actually what we call as a local axis. Local axis is the axis measured on the car itself. Okay, so meaning that if your car direction, okay, this is actually your car center line. So this one we consider this one as a car x-axis. Okay. This is ini, okay, yang ni local axis of xy, yang ni global axis of x, global axis of y. Okay, ada beza sebab yang ni x axis belong to global x, bigger x direction, and then this one belong to the y global or y bigger y, okay, direction. So for this one, for x global axis, x and y, this one depend on the car itself. Okay, so for x-axis being draw straight from the car x-axis yang tadi kita tengok, yang ni sideways direction for y, perpendicular to this one. So whenever you steer your car, you're going to produce car steer angle, which is this one. Okay, and then the way that we measure it is actually from the x-axis to the direction of the wheel center line lah, which is this one. And then prior to the motion of the steer of the wheel that being steered, we're going to produce yaw angle. your angle is actually being measured from global axis of x into local axis of x. Okay, which is this one. This one is x, big X. This one being measured from here to here. Okay. Okay, angle between x-axis of Earth fixed system and vehicle x-axis. Okay, yang ni. Okay, x besar ke x kecil. Ini yang beza, ingatlah. Ini your angle. And then people usually tends to confuse with your angle the cos angle. Cos angle yang ni, dia measure daripada x-axis x besar ke current velocity. So meaning that bila awak turn sepatutnya kalau bila kita buat turn vehicle, usually before we reach the velocity that we want, we still have the current velocity, which is the previous one, which is the initial, like lag lah. So that cos angle being measured from this one to that previous velocity achieved. Okay, yang ni. So ini kalau bila awak turn, so we expect the velocity direction going to be in this, going to be the same yang kita tengok yang ni. Okay, tapi sebenarnya tak, course direction yang ni kita measure daripada x besar ke yang previously achieve velocity direction. Okay. Faham untuk ni, jangan confuse antara cos angle dengan your angle. Okay, and then we have a lateral acceleration lah. So lateral acceleration usually we're going to measure in terms of centripetal direction or in centripetal lah. So based on this figure, we are actually turning to the left. So the vehicle lateral acceleration based on the sign or the axis, standard axis that we see in previous slide, the axis direction is always in inside direction. Okay, this is actually centripetal. Kalau kita ada centripetal direction, ini centripetal direction. Yang keluar ni centrifugal direction. Okay, for vehicle dynamics, we consider the lateral acceleration is actually the centripetal force. Okay, faham So ini term ni awak kena jangan confuse lah. So your angle, slip angle, cos angle, steer angle and lateral angle. So other than this, so we're going to go and see in the handling topic. So any question? Ada tak?
No.
Okay.
So far, so
Now,
good.
okay. Ini yang tadilah. So ini saya dah terrepeat dia punya slide ini, kita dah bincang sebelum ni. And driver input. So driver input ni going to produce lateral dynamics and longitudinal dynamics, which we're going to study. So based on this study, we come out or derive control system for improving controllability and stability of vehicle furthermore. And then despite of only the driver be able to give input, vehicle also will give input back to the driver to evaluate the current environment or situation while driving. So that feedback can come in terms of vibration, sound, and also being provided from the instrumentation that being installed in the car. So that's it for the introduction. So any questions? Ada? Ada? So kalau tak ada, so that's it for class today. So
Doktor, nak tengok
Yes.
balik slide yang angle tadi tu, the axis.
Yeah.
This one.
Ini.
Bawah. Yang nombor 11.
Ini.
Yeah.
Okay.
Sekejap. Yang beta tu, the
Ah.
angle beta. What is the difference between the x-axis tu and VA?
Oh, okay. Okay, dia macam ni. Dia kalau yang tadi saya buat, ini contohnya lah, bila when we make a corner, usually the speed in front of us is actually this one. Sorry. This one. This is actually that we are feeling, but not with the car because it still stick to the previous speed. Contohnya lah masa awak ambil corner, awak tekan pedal kan. Awak tekan pedal, so by means that it start moving from slow to fast, correct? Okay, the one that in front of you, let's say that you are pressed, so let's say that this one is 50 km per hour. This one, before you achieve 50 km per hour, you need to remember you are pressing your pedal, right? So meaning that the previous the previous speed before you start feel that direction is actually this one, VA. And then this one, let's say you can say that 40 km per hour, 48 km per hour, sorry. Okay, ada hilang. Okay, yang ni V. Nampak atas slide yang saya tulis ni?
Nampak.
Okay, so let's say that this V, contohnya lah lepas awak take a corner and press pedal, and then the front direction or front velocity that you feel is 50. And then before you reach this 50, of course there is going to be a slower speed, and that slower speed is this VA. So let's say that this one is 48 km per hour. Okay, this one and this one, in order the differences between the previous velocity and the current velocity that you're feeling, that one is actually the slip. So this one what we call as the vehicle side slip. So meaning that your car won't immediately cause or have the dia punya velocity that you retain lah. So maksudnya dia ada slip lah. Awak tahu kan slip kan macam mana, apa beza slip? Contohnya macam awak nak pergi this one involving response lah. You want to go to that level, but you cannot immediately achieve that. Okay, and then by the time itu kita panggil lebih kurang macam slip lah. So meaning that there is a deviation, unprevented deviation. Tapi akan capai, tapi lambat lah. And then another contoh of slip is that contoh macam wheel slip lah. Contoh lah, okay, macam contoh ada motor kan, motor rempit kan. Contoh lah, ni ke motor ni kereta ni. Yeah. Okay, contohlah awak. Contoh awak ada motor, lebih kurang lah. Okay. So kalau ada motor, contohnya lah, kalau motor, kalau awak press, pusing di throttle slow, motor awak akan ke depan kan, slowly, betul? Okay, itu tak ada slip. Itu kita boleh katakan awak punya wheel ni, dia tak ada slip. Tapi contohnya lah, and then second case, cuba awak suddenly pusing awak punya throttle, terus rem kan. Kalau awak lepas ni, sama ada awak akan wheelie ataupun dekat awak punya tayar ni, dia akan tayar awak basap.
Oh, okay.
Betul? Maksudnya itu slip. Maksudnya dia tak immediately pergi ke level yang awak nak. Maksudnya sekarang ni untuk kes motor ni dia tak terus ke depan lah. Dia macam, dia pusing dulu, basap dulu bawa motor awak ke depan. Sama jugalah dengan yang ni, untuk side seat yang ni. Meaning that your car is actually having a slip, but in the form of in a Z direction lah. So meaning that it won't immediately go into direction that you want. Itu slip, side slip angle. Faham dia punya?
So that means the vector for X and VA ni dari segi velocity lah.
Velocity current dia macam yang current velocity yang ni yang kita nampak. Tapi yang sekarang ni sebab vehicle is actually involving a big inertia kan. So still affected by the previous speed lah. So that one is inertia. So this one it cause the side slip angle.
I see later. Okay. And then meanwhile the dash punya line tu is the trajectory lah.
Trajectory. Yang ini trajectory. Okay.
Alright.
Faham
Okay, faham.
Yang lain ada soalan? Ada? Kalau tak ada, so we can dismiss our class. So thank you. So see you besok ada kelas lagi ya, satu jam. And then awak dah tahu kan, 3 hari bulan tak ada kelas, 3 dengan 7. Tak silap saya lah. Mana-mana kalau awak ada subjek yang ada kelas 7 hari bulan, kelas 7 hari bulan tu cancel lah. Dah ada berkeliling. Yep.
Ya, betul.
Kan? Okay, thank you. So, okay,
thank you.
see you tomorrow. Okay, petang ni ada AD je kan? Okay, discussing. Okay, thank you. Then we can dismiss. Okay, Assalamualaikum and thank you.
Thank you.